In this lesson, we are going to look at indices, then also look at the laws of indices. Then we'll look at when a base is raised to a fraction, and so on. Now the first one, let's look at some basics. We have x raised to the power y and 2 raised to the power 3. Our x is known as a base, and also our 2 is known as a base. Our y is known as an index or an exponent. Then the power is the number raised to an index or exponent. So the power tells us the number of times a base is. Now let's look at the first law of indice. So the first law of indice, we'll look at multiplication. Now in order for us to apply this law, we need to make sure that we have the same base. For example, if we have a raised to the power m times a raised to the power n, so we can see that we have the same bases here. So we just get one base, a, then we add the indices. Let's say we have 2 raised to the power 5 multiplied by 2 raised to the power 3. So this can be simplified as 2 raised to the power 5 plus 3, which is same as 2 raised to the power 8. So what we are saying, if the bases are the same and you have the multiplication, add the indices. So the addition comes in as you are dealing with the multiplication. Now let's move on. Let's say we have this division. Now division is the opposite to multiplication. Instead of adding the indices, this time we are going to subtract. So if we have a raised to the power m times a raised to the power n, so we just say a raised to the power m minus n. Okay, let's say it's the same question. If we have 5a raised to the power 5 times 2 raised to the power 3, this can be simplified as 2 raised to the power 5 minus 3, which is 2 raised to the power 2. So division, you subtract the indices. Now the next one, raising, let's say we have raising a power to an index, also sometimes called the double indices. So let's look at the double indices. So the double indices can be simplified like this. This time, if we have a raised to the power m brackets raised to the power n, this is equal to same as a raised to the power m n. So you just multiply the number inside the bracket times the power outside the bracket. For example, if we have a raised to the power 2 enclosed in brackets multiplied by raised to the power 3, this is same as a raised to the power 2 3 times, since we have the 3, so 3 times. So which is we can say here the first bracket is a times a, since a squared times a times a times a times a. So if we can go back to the first law of indices, we can see that we have the same bases, then they are all raised to the power 1. So we can get one base, which is a, then we add the power. So we can see that the indices, they are 1 plus 1 plus 1 plus 1, which is raised to the power 6, which is in a simplified manner is, if we have a problem like this one, we can just say 2 times 3, which is a raised to the power 6. So this is our double indices. Now let's move on to another where we are going to have raising a product of factors to an index. Raising a product of factors to an index. What we are saying is, if we have A times B in brackets multiplied by M, this is the same as when raising a product of factors to an index. The result is the same as raising each factor separately to the index. What it means is the A times B in brackets multiplied by, raised to the power M is same as A raised to the power M times B raised to the power M. Okay, let's say we have a numerical value of 15 raised to the power 3. So we're going to look at the two numbers that we can multiply to give us 15. So we just use 3 and 5. So we can see that our 3 represents the A, then 5 denotes the B raised to the power 3. So as we can see, we can expand the usual way. 3 times 5, first bracket, 3 times 5, 3 times 5. So we can see that since we are raising this bracket to the power 3, it means we have 3 pairs. So what we are going to do is we are going now to separate. The 3's will be on their own. So we begin by 3 times 3 times 3. Then we can get the 5's. So 5 multiplied by 5 times 5. So as we can see here, we have 3 raised to the power 1, 3 raised to the power 1, 3 raised to the power 1. So if we use the first law of indices, where we get one base, then we add the power. So 1 plus 1 plus 1 is 3 times here we also get 1, 5. Then they are all raised to the power 1. So we can add the indices, which is giving us 3. So therefore, if you have a problem where you have 15 raised to the power 3, you just need to find the factors. So the factors of 15, like we said, are 3 and 5 raised to the power 3. Then this 3 is raised to the power 3, also 5 is raised to the power 3. So this can be simplified as 3 raised to the power 3 times 5 raised to the power 3. Now let's look at some examples. Use the laws of indices to simplify the following. Okay, now let's look at the first example that we have. So 5a raised to the power 6 times 2a raised to the power 4. So first we'll begin by looking at the numbers. So we can check. The first part has 5. The second part has 2. So we can see that the bases in terms of the numbers are not the same. So we're not going to use the laws of indices. We are just going to multiply the usual way. So 5 times 2, we get 10. So you multiply. So in cases where you have maybe letters or numbers and they are different in terms of bases, you need to multiply the usual way. So 5 times 2, we get 10. Now let's check for the variables. So our a here is raised to the power 6, then the other a is raised to the power 4. Now there we can see that we have the same base, so we are just going to get 1a, then we add the powers, which is 6 plus 4. Then we continue. Here we are going to have 10 times a raised to the power 10. So this is how we can simplify a question like this one. Now let's move on to Roman number 2. Here we are dealing with division. So the first step that we are going to do is we are going to convert this fraction by introducing the division sign. So what we are going to do is we have a raised to the power x plus 1 divided by a raised to the power x minus 1. So this line means as a division, so you can write it as a division. Then after introducing the division sign here, we are going to look at the bases. We are going to ask ourselves questions like, are the bases the same? So we can see that the bases are the same because the first base is A and the second base is A. So we get the A. Then the first power is x plus 1. Then we said as long as you are dealing with the division, you subtract the indices. So minus x minus 1. Then here we have A raised to the power, so x plus 1. So we are going to distribute our negative with everything in the second bracket. So negative times x, we get negative x. Negative times negative 1, we get positive 1. So if we collect the like terms, we can see that we have x plus x minus the other x is negative, so x minus x plus 1 plus 1. So here we can see that we can cancel this one because x minus x is 0. So our A is raised to the power 2. So this is how we can handle a question like this one. Okay, let's see then our Roman number 2. Roman number 2 here, we remember we can just multiply the power outside multiply by the power inside. So this is as simple as 4 times 5, which is equal to 20. Then for this one, our 3 is raised to the power 1, our x is raised to the power 1. So these 3 will multiply by each power inside the bracket. So what this means is we have x raised to the power 3 and 3 raised to the power 3 and x raised to the power 3. So this is our final answer. But if want, we can also simplify the 3, or where we have 3 times 3, 9 times 3, we get 27 multiplied by x to the power 3. So this is how we can use the laws of indices to simplify a problem like this one. Now let's look at also simplify expressions with positive, negative and 0 indices. So now this law of 0 indices is anything raised to the power 0 is 1. So let's say if we have A raised to the power 0 is 1, negative 10 raised to the power 0 is 1. So anything, whether the number is positive or negative, it's a small number or big number, any letter, as long as it is raised to the power 0, it is equal to 1. That is also another rule, and we have to make sure we understand this because these laws are also applied under calculus. When you are differentiating and it gives you a letter raised to the power 0, you just need to replace that with 1. So anything raised to the power 0 is 1. Now let's say we have 3 raised to the power 3 okay, not let's use it. So A raised to the power 3 divided by A raised to the power 5. So if we can go back to the laws of the first one where we have the division method, we said we need to subtract the indices. So we can see 3 minus 5 is equal to A raised to the power 3 minus 5 is negative 2. Now there are some times where you are asked to leave your answer as a positive index. So meaning we want the index or the power to be positive. So what you do is if you are converting a negative index to a positive index, we need to just say 1 over, so 1, this negative becomes a 1, then the remaining part will go on the denominator side. So 1 over A raised to the power 2. So that is how to do with a negative index in order to leave it as a positive index. Same applies. So if this A were to go back on top, the negative will we have to add the negative to the power. Or maybe let's just view it in this way. Let's say a to the power 3 is divided by a to the power 5 can be written like this. So we can see that we have a times a times a over a times a times a times a multiplied by a. So we can cancel one a from the numerator and one a from the denominator, another one, then another one, another. So you can see that on the numerator we only have 1, over on the denominator we get 2a's. So we can see that we are still able to reach the same position. Now let's see how we can simplify the following. So the first part here, we can say a raised to the power 4 divided by a raised to the power negative 7. So by using the laws of indices, we are going to say a 4 minus negative 7. We say that whenever we see a division sign, we subtract the power. So we get a negative times negative, we get 4 plus 7, which is the same as a raised to the power 11. Okay, maybe let's try to divide it in such a way. We know that a raised to the power 4 is divided by, but this one, let's write our negative 7, a raised to the power negative 7 as a positive index. We said this will be as a raised to the power 7. So I'll write it as 1 over a raised to the power 7. Then let's do the usual step. So we are going to change this division into multiplication sign. And when we do this, we know that now the denominator will go on top, the numerator will go on the denominator part. So we are going to have 7, a to the power 7 over 1, which is just the same as a to the power 7. So you can see that we can now apply the law of indices for multiplication, where we can add the indices. So we can say 4 plus 7, which still is giving us 11. Okay, so now let's see. Here we can write each number as an expression with a positive index. So the first one is a raised to the power negative 1, our b. So you can pause the video and try to work them out. So these numbers here, they are all raised to the power to a negative power. So our question is, we want to write these expressions now with a positive index. So the first step here, you can just say 1 over a to the power 1, which is 1 over a. This one will be 1 over 5 raised to the power 2. This one will be 1 over raised to the power 1 over 2 raised to the power 3. Then this one will be 1 over 25 raised to the power positive 1. So this is how you can simplify expressions with negative index. Okay, now let's look at how do we simplify expression that contains fraction indices. So let's say we simplify the following without using a calculator. Okay, so the first problem that we are going to look at is 8 raised to the power 2 over 3. Then we'll have maybe another problem, but this time 8 raised to the power negative 2 over 3. Then the third one, we'll just look at 3 to the power 0 plus 1 over 4 raised to the power half. So now here we are dealing with a base raised to a fraction. Now let's begin with the first one. So we have the formula like if we have, let's say, m raised to the power a over b. Our a is known as a root. Our b, not a root. Our a is known as a power. So we get the power. Then our b is known as the root. So this can be expressed as the m. We know that the m is the base. So the base should always be written under the square root. Then here you put the root, so b, our root, then everything raised to the power a. So that is the formula we use whenever we are dealing with indices with fractions. So let's look at the first one. So the first step is we need to write the square root. Then under the square root, our base is 8, so our 8 is here. Then our root is 3. Then everything raised to the power 2. So we can find the third root. So the third root of 8, we are looking at the number that we can multiply by the same number 3 times to give us 8. So 2 times 2 is 4 times 2 is 8. So the third root of 8 is 2. So we get 2 to the power 2, which is 4. Okay, let's have where we have a negative. So the only difference is step number 1, we need to convert this into a positive index. Then from there, we need to simplify it the way we did to part number 1. So what we are saying is 1 over 8 raised to the power 2 over 3. Then from there, the denominator part will be simplified as usual. So we get our base is 8, our root is 3, then raised to the power 2. 1 over the third root of 8 is 2 to the power 2, which is 1 over 4. So if the power is a fraction and also a negative, then our answer should give us a fraction. But if the power is positive, you may have a number as a whole number. So now let's look at the way we can simplify this one. So on top we can see that 3 is raised to the power 0, and we said anything raised to the power 0 is 1. So 1 plus 1 over. Now for the denominator part, we can see that we have a fraction, so we are going to simplify it the way we did with the first part. So what we are going to do is the square root. So the base, from there we can see that the base is 4. Then our root is 2. Now we don't show the 2. 2 is denoted by the square root symbol. Then everything raised to the power 1. So on top we can see that 1 plus 1 is 2 over the square root of 4 is 2. 2 into 2 is 1. So these are just some of ways in which we can simplify indices. That's it for this video. Thanks for watching, and please remember to share with our friends and families, and don't also forget to subscribe if you have not done so. So thank you so much.